So here's a couple of problems that take things a little bit further. So this example is also from the textbook, chapter 3. This is number 35 and 36 in at the end of the chapter in the problems. So this example, we're going to ignore the first part of this description, but we're looking at roughly 1,134 observations that were made, and what came about after making those observations was that the curve was relatively normal, and it had a mean of 22.2 miles per gallon. We're talking about fuel efficiency, by the way, fuel economy, and a standard deviation of 5.2 miles per gallon. So right there, we can actually start to formulate some assumptions. So one is it's a normal curve, so I can draw that out because that's what I should be doing when I see something, see a problem like this. I should draw a normal curve out, and it gives me some good information here. So it says that the mean is 22.2. So I'm just going to write up here in the corner, mean is 22.2. And the standard deviation is 5.2. So sigma is 5.2. So right there I have a good piece of information. I can actually start putting this information onto the chart. So the mean is here, and that is 22.2. So I already have a piece of information. Now I also know the standard deviation, which is 5.2. So I can start, throwing that in there as well. Probably not as significant at this point, but we can look at it. So standard deviation to the left is going to be here, and it's going to be the mean less 5.2. So 22.2 minus 5.2, and for some reason I'm having a math issue in my head. So 22.2 minus 5.2 is 17. So this one standard deviation here is going to be, it's one standard deviation, so that implies that this is 17. And on this side, on the right side, it's added. So 22.2 plus 5.2 is going to be 27.4. And this is at the standard deviation, one standard deviation. So right there I sort of have a range here that I'm looking at, but really the first question, I love my bug, it says the 2014 Volkswagen Beetle with a 4-cylinder 1.8 liter engine and automatic transmission has combined gas mileage of 28 miles per gallon. Well, 28 is outside of this standard deviation, the one standard deviation. So 28 is, somewhere around here. So right there I know I'm dealing with a number that's higher than what I've already computed here. So it says, what percent of all vehicles have better gas mileage than the Beetle? So if the Beetle is at 28 miles per gallon, so let's just say that that's here. The question becomes, what percent is greater than, so this part of the curve is greater than 25 miles per hour. So what, miles per gallon, excuse me. So what is the percent there? So this is where we can either use the calculator, a statistical calculator or Excel, or we can just use a table in the back of the book. So the first thing we need to do in this portion of the problem is to figure out what the standardized score is, and that's the z-score essentially. So we know that the z-score is, and I'll write this down, the z-score is going to be the value that we're targeting minus mu over sigma. So the value that we're looking at minus the mean over the standard deviation. So in this example, this would in turn be the 28, which is what we're targeting here. So the 28 is the gas mileage that we're targeting. 28 minus 22.2, which is mu, over 5.2, which is sigma. And if we do the math on this, and I'm just going to go to the side here and do the math quickly. So 28 minus 22.2 is 5.8 divided by 5.2 is 1.12 roughly. So this is equal to, the z-score is equal to 1.12 approximately. I rounded up, it's actually 1.11538.462, but this is the round. So now that I know the z-score, I need to go to either Excel or the table, and in this case we're going to go to the table, and we're going to look the z-score up to figure out what the percentage is. Okay, so for lack of being able to have this this image in my camera roll, I'm just going to do this the easy way, which is just to show you live what I'm looking at in the book. So this is the book, and this is the back portion of the book, and you can see this is table A, standard normal cumulative proportions. So our number was 1.12. So if I look at this table, I can see that 1.1 is roughly half, a little bit, the second white area here, and that's 1.1 under the Z column. And then if I go over, I know that this is 1.12, so 1.1, and now I can go over to the 0.02, and you can see here that that is 86.86, or I'm sorry, 0.8686. So that is our value for the cumulative proportion. So let me just turn that off for a second. So now I'm going to go and I'm going to say, so our cumulative proportion is 0.8686. And what that tells me is that 86% of the population falls below the 28 miles per gallon. So essentially what we just calculated here, because when we use the table, it's always using the values to the left of whatever target we're looking at. So this is 22.2, this is the mean, and we just found out that this is 28 right here. What we just determined by looking up in the table, we just determined that the value that falls under this part of the curve here. This is roughly 87%, which means that the rest of it, because we know that if we total everything up, it's going to be 100%, the remainder has to be 13%. And so that's how we approach this particular problem. I'll make a second video that will show us how to do the percentage in the other direction. So if we're trying to find a value that would fall within a percentage. So I'll do 3.36 in a separate video.